Good afternoon to you. I know that. Yeah. Hasita, only three of us. So shall we wait for 5 minutes? කොහොමද පුතා විනාඩි 5ක් විතර බලමුද?
ඕනේ සර්.
ඔව් නේ? හරි. Okay. This, yeah. So this one. Let me check that. Yes. So today third revision. So even in second revision, we have learned about this. Okay, go through the notes and go through the supplementary videos and the supplementary sessions. So this is in your notes. You can understand this very well. So this is a guide only. Today I'm not going to explain because these were well explained those days. Yeah. And you work on this solved example. Okay, solved example, work on this. Yeah, those are very simple ones. You work on the solved example. So I'm going to put it here. Okay. Solved example, go through this very well. This one, it's in your notes. Okay. So understanding is very important. The solved example. You look for your notes. Yeah. So this is only explain this expansion process, but this looks quite interesting because it's very important, this knowledge. And similar way, you can look into isentropic compression. Okay, isentropic compression, the same way you should be looked into. Okay, isentropic compression. Actual process and isentropic process. Actual process and isentropic process. Okay, isentropic process is considered an ideal process. Also, you may work into this. Okay. These questions. You can pass this to me as well. There's 10 questions. in your notes. Okay, 10 questions. So look into the notes. You can say this quite clearly. You can say this quite clearly. Okay. Here, if I look into revision 2, okay, now I'm going to share with you the revisions 2 slides. Here you can see isentropic expansion. Well explained this one. Okay, isentropic expansion. And then even the isentropic efficiency, here isentropic compressions. Okay, so comparison, and we develop the expressions for isentropic efficiencies for expansion and compression. Okay, so you have to follow this video very well, and the exam focus question is there. Okay, exam focus question is there. So here in the revision 2, you have minimum 2 questions. We are talking about this entropy related because here the core objective is understanding entropy. See, thermodynamics B1, B2, understanding entropy. This is very important. Important in the sense, and the conservation of energy and energy balance, those are quite phenomenal, and you can do the calculation or whatever to have the energy balance, energy audit, whatever. But when it comes to the effectiveness of the utilization of energy, okay, you have to look into entropy. That is very important. So understanding entropy. This slide, 70 slides are here. I have sent you this note. 70 slides are here about understanding entropy. This is very nice. You can see how important, okay, the understanding entropy is. That's why definitely in the revision 2, you will get 2 questions at least. And even the vapor power cycle, okay, this expansion component here you can see, or even in compressions, this compression part, maybe in refrigeration or whatever. So this part is separately discussed based on this reference to ideal and actual. Okay, ideal means isentropic. See, isentropic. Actual is non-isentropic. So you have to understand this. Okay, so questions are very simple because knowledge should be very simple. Okay, don't expect complicated questions because your thermodynamics knowledge is simple, and I will make sure that the simple questions are there for you to reflect your good knowledge. That's all. So the simple but quite standard questions I will be posting in the exam paper. Yeah. So don't worry about this. Understanding is very important. Okay. So that's why here in the revision 2, because I have to refer this to you as well, because I have done this with B1 batch. Same way, revision 1 I have done with you and I posted it to B1. Revision 2 I have done with B1 and posted it for you as well. Third revision today I am doing with you, but I will be sharing this with B1. And final session maybe next Friday with B1, and maybe I will be meeting you as well on Saturday. Next Saturday will be the last session. Okay, so this is the B2 one. I send you the notes and very useful ones. Understand entropy. Read this, read other literature, read from the web. Yes, and make sure this kind of applications are entropy related. It's not only that, related to power cycles, but without having knowledge of entropy and the isentropic efficiency, see isentropic efficiency is here, you cannot respond to this. Because isentropic is what we need to know. Okay, it has a very good practical aspects. Okay, very good practical aspect. It's a useful and workable knowledge is there behind entropy. So if I didn't do entropy well, and if I didn't focus entropy in the exam, so I may not be doing right. That's why you have entropy related at least 2 questions there. Okay, that's all. So even today, your revision 3 discussion. Okay, even today, revision 3 discussion. I put here applications. See, isentropic efficiency is there. Means we are done. Okay, and here the reversible, you can see reversible, reversibility and irreversible processes and TS diagram, the topic under this. So you look into the notes, you can see this big in the notes and solve this. Okay, solve this and pass to me as an assignment. Okay, so you will get CA marks as well, and based on that I can look into the paper what kind of questions I'm supposed to post. So please make sure that you have this pristine, very valuable knowledge. That is very important, and this is not for you just to do question and answering. This is about understanding. Okay, this is about understanding. Okay, and here you can say further, if I look into your notes, yes, if I look into your notes, see, if I look into your notes, so we have discussed vapor power cycle without referring to this, but the note itself, you can see vapor power cycles, Carnot cycle, and the ranking cycle. Okay, should be there. But here about the heat exchangers. So I'm not asking about heat exchangers. Okay, so that is that. Vapor power cycle is here. Okay, vapor power cycles. Very interesting. Have to have the very basic knowledge. You connect this knowledge with whatever in the class notes. Okay, this is your text, and the videos you will say this. Okay, disadvantages of this. I think you know this very well. So please go through this Carnot cycle, the vapor power cycle. Okay, Carnot cycle, and then you have the ranking cycle. Okay, ranking cycle, we have learned this. Okay, ranking cycle, we have learned this. Okay, and then reverse of this. Reverse of this. is the refrigeration. So you have the Carnot cycle here, and the reverse practical refrigeration cycle is, I think you have to refer the notes. This is little okay. This is okay. Okay. So practical refrigeration cycle. So even solutions are there. Don't worry. You can understand. So this is about vapor power cycle and its reversal refrigeration cycle. Okay. So that is very important. So I'm referring the notes here. So from page 45. Okay. From page 45 to page 50. Okay. 51. You should understand this. Page 45 to page 51. And somehow you looked into this. Okay. Refrigerator question. Okay. Carnot's a refrigerator. And this is about, again, the reverse, about refrigeration. Okay. So you have the solved example. Yeah. So just doing this is enough. For power cycles, you have this tutorial. Okay. So you have to do this. Okay. So page 45 to page 56. Okay. Page 45 to page 56. So I will write it here today. So after this, page 45 to page 56. 11 pages to understand. Okay. Page 5 to 45 to page 56. Okay. This one. This is about vapor power cycles. Here in the sense, Carnot and Rankine. Okay. Carnot cycle is a very basic cycle. There are practical issues. You have noticed that. We have discussed that. Okay. Vapor power cycles, Carnot and Rankine. I have to look into this. Good. And then the other one is vapor compression, refrigeration cycle. Cycles. So that is reverse Carnot and of course reverse like Rankine. Reverse like Rankine. So you know about this well. Reverse Carnot and reverse like Rankine. So why should I say so is, if I look into previous, okay, knowledge build-ups. Okay, you can see we have learned a lot. Okay, we have learned a lot, and this is about refrigeration. Okay, this is about refrigeration. So you have this knowledge. Okay, so here pH diagrams and lot of things we have developed. So this is am I putting the right one? Yeah, yes. So this one is okay. So you can see we have learned a lot. So definitely this kind of models, modeling of this, you should expect, because these are very important modeling parts. You can see, so for you to remember, let me put, see, power plant, steam engine. So this is the power cycle. Okay, this is refrigeration cycle. Okay, refrigeration cycle. So nice. Okay, so nice. I will put here, because once you learn either refrigeration or power, the other one you can learn easily. Okay, copy. I will look into today. Revision. So this knowledge, okay, we have together developed this. So this kind of models when it comes to energy analysis and all, very important, very nice. I may be using the similar ones exactly from this notes. Okay, this is one. And give me a second. Give me a second. Another video. We have 7 today, including myself. Fine. Okay. Here we understand flashing, but this is a continuation of refrigeration cycle. You can see how we have developed this pH diagrams and all. So nice. Okay, see, all well explained, not like in the textbooks. So if you look into the videos, you will understand this very well. Okay, this is TS diagrams. Then from this ranking cycle also we have developed this. This is a very important video again. Okay, I believe I have passed this to you all. Okay, see Carnot cycle, reverse Carnot cycle. Then you have the Rankine cycle. Okay, for the power plants, vapor powers. Again, this concept development you can see. So you have to go through this together with the video. Okay, very important. Okay, together with the video. This is the refrigeration. Okay, that is very important. Otherwise, if you just take only one slide and refer anything, you may have issues. Okay, you have to follow the video as well. Okay, because see example a combination you can see. The refrigeration cycle, how we are going to change it to power cycle. So the Rankine and the reverse, TS diagram of the refrigeration cycle, vapor compression. Combine one. See compressors here, turbines. So your the boiler is here, condenser is here. Feed pump expansion valve. Okay, your boiler is here, and also there may be evaporator. See, evaporation. So condenser and evaporation. Yeah. So that's how. So this is another very useful note. Okay. So very seldom you have this kind of notes. Yes. So flashing and liquid seal, learning 7 points. Understanding and analysis of pH diagrams for practical usage. These are very good ones, you know. Yeah. 7 points. Very important. So even I'm referring these to set the questions. Believe me. Okay. So it is very important to learn this technology. We call technology. Okay, technology. As I mentioned, here you can see a lot. Okay, that's all. So definitely you will have the questions about liquid seals, understanding flashing and technologies. Okay, so nice. Okay, so this is another master notes. Okay, for our exams. Very good. So do I need to put some of the slides here? Maybe I will go for selected ones. Okay, I will go for some selected ones. Some selected ones for you to keep your memory. Okay. See, we talk about entropy and all. Copy. I will copy this to today's presentation. Paste. Yes. Okay. This is today's presentation. Not to say presentation revision 3. 2019. Yes, 2B1 and B2. Okay. Thermodynamics. Revision 3. Okay. So I'll put the date as 6 March. Okay. So this is the one. So you can have some guidelines here, but definitely you have to go through this. Okay. So I have to mention one more thing. I can see that some have participated consistently. Okay, some. Yes. Some have participated consistently, but some have not. That is okay, but those who participated, they have a better understanding, and when it comes to the exam, they have a leading edge, but that is natural. Okay, that's why. So don't expect from me the model questions like things. Of course, there are questions I'm putting. Even I passed you here to understand this, but don't expect exactly the same things. Yeah. So question, just practice this. You will get the exam question the same way. No, because then it's an disadvantage because some are not following. They may looking into the revisions and then they think that, yeah, only this one when we can manage, yes. Maybe only 30% may be there, but for the next balance of 70%, it is based on total understanding. That's why you will have the questions, including flashing and all. You can see it. So have a very good understanding. Even I will put one simple question for you. The way you feel the subjective thermodynamics. So I will put that one as well. So those who have the interest, so they can score the marks. Okay, they can score the marks because we have covered the syllabus. So when we set the paper, so we will look into a lot of qualities and attributes expecting from you. And those will be in the exam. It is very easy one. This exam is very easy, but you have to understand this. Okay, no memories necessary for this case. Okay, so I put these things here for revision 3. So this is continuation from revision 2. Still focusing on entropy. And then this modeling, these models, it's very nice, okay? Very nice, and these are thermodynamics. Some theoretical aspects we have connect with practical. See, refrigerator is here, the model is here, okay? So very seldom you can have this kind of colorful and well-connected diagrams, very seldom you see. Even you go through, you browse the internet and see whether you can find any refrigeration like or whatever in this class of presentation. Not possible. There can be animations, true. But building together in this way, see S1, S2 isentropic compressions. So this kind of complete dialogues, presentations, very hard to find. Okay, that's right. So that is my part. So I had to do something special for you and I have done it. Okay, so it's your part now to understand this. Okay, that is your role. So that is very important, Pratana. So here, from the revision 3, you must expect minimum 2 questions. Okay, minimum 2 questions here. Because you have the vapor power cycle, you have the reverse refrigeration cycle, and there are a lot of practical aspects. Even entropies about the flashing, right? Maintaining pressure differences. So there can be a lot of practical aspects as well. So these things you have to understand, okay? These things you have to understand. It is very important, okay? So let me put something for some more reflections. Okay. These are questions I put in the previous paper. So let me share it with you. I think I will go through the paper first. Where is this one? Okay. See one question here. Some components. See. Complete the table. Okay. Yeah. In your answer script book and fill in the blanks by considering contrast and similarities, etc. in processes and components. So you have refrigeration, steam power plant. So matching the components. So your knowledge, you definitely must have a good knowledge on this. Some questions. Like the compressor in the vapor compression, what components makes the flow of working fluid in steam power plant? See, isentropic expansion, the best possible theoretical limit of turbine efficient work done. Explain the concept. And then a simple question. Not a difficult one. So you have to know this precisely. Otherwise, when you have the efficiencies and some work, so you will do some wrong calculations. So you have to precisely know this. Okay, so just one example. Yeah, okay. See, the learning of entropy from property tables. Very basics, but consider very important. See, rice cooking, racing car engines, refrigeration with better insulations, about water boiling. Yeah. Simple questions. Because they may have some practical aspects, so we will put this kind of things as well. Yes. So, good practices in the using of refrigerators. So you have to connect this knowledge with the technology and theory. Simple lifestyle with second law. Okay, second law means your knowledge about entropy. Okay, second law means knowledge about entropy. That's it. Okay. So you can see some simple questions. See, what are the components responsible for the making high and low pressure signs? Yes. And explain how this high and low pressure buildup is maintained when in operation. So that's why you should understand this about the liquid seals and all. See, name the component of the system causing flashing effect and explain how important the flashing effect in the vapor compression refrigeration system. Explain why the four major components need a good matching. Explain why the refrigeration is called the working fluid. So you have to write very clearly and precisely about the COP. Okay. So it's very nice. Okay, it's very nice. So this is a blend of technology, your concepts, even some analysis and all. Okay. See, referring to figure 3, this is refrigeration. Asking to draw the vapor power cycle, draw a schematic similar showing in the steam power plant. So you have to do this. Referring figure 3. So you have to develop this. And you have to show all. Okay. So this is just one section on the 6.1. And this has until 6.5. Okay. There are sections, of course. Even question 5, there are five sub-questions. Question 4, you have 4 questions. See, question 1, question 3, you have 4 sections. All simple but important. Now, I feel that you should know what kind of a blend our thermodynamics paper is having. Okay? Our thermodynamic paper is having. So, that is good really. Okay? So, steam tables will be given in the appropriate sections. Even there can be, yes, everywhere you will get the appropriate tables. Okay? So, quite interesting. And this time we have done better because we spend a lot of time. Okay, we spend a lot of time. We develop note together, not like in the face-to-face, we just put the presentation and discuss, but here, as it's a challenge in Zoom sessions, we develop it together. So, we have done something very classy. Okay, so from this section, you can expect minimum 2 to 3 questions. Three questions. Okay, from this. So, this is from revision 3. Okay, minimum 2 to 3 questions. So, revision 2, also minimum 2 to 3 questions. Revision 1, okay, you can say 2 questions, okay, not to say minimum, let's say 2 to 3, 2 to 3, 2 to 3, 2 to 3. Yes. And from the vapor power cycles and the refrigeration, this revision 3. So, after that, so I think it is not necessary to do revision 4 because Diction mal lecture එක තියෙන්නේ මේ lecture එක තියෙන්නේ පැයක් ඇතුළත කතා කරන්නනේ. Okay. 4:00ට පුළුවන්. ඔව් හරි. Okay. හරි. Yes. So one more aspect here, I will put that as, okay, again, let's say if I put this as revision 4. Revision 4, you may have 2 questions, 1 to 2 questions. To 2 questions. Questions that is about gas power. Okay, gas power cycles. Gas power cycles. Okay, so no much analysis this time. So we will check the technological knowledge. So we have done 2 to 3 sessions of gas power cycle lessons. Maybe we have done 2 to 3 sessions. 2 to 3 sessions we have done. Okay, so there will be minimum 2. So 2 times 2, 2 times 4 is 8. So somehow there will be 8 questions. So 8 questions, no sections maybe. If anything more than 8, we will have sections. Part A, part B like this. Okay, and part C. So out of 8, you may need to answer 5. Okay. And, okay, so revision 4. So I'm not going to do a separate revision. Okay. As revision 4, you just go through this videos of gas power cycles. We have done those in very good way. Okay, revision 4. So look into your notes. Okay, no separate revision for gas power cycles. Okay, so that's it about this. Not finished yet. Okay, not finished yet. For a paper, of course, there is a syllabus, but there should be a theme for the paper. Okay, there should be a theme for a paper. That is not a big deal. Okay, there should be a theme for the paper. Okay, themes, not one. Okay, so I will put one by one. If you don't talk about environment, okay, thermodynamics and environment, so this is one of the themes. Okay, second, thermodynamics, and of course thermodynamics and okay, innovations. So I will guide you through this innovations and entrepreneurships. Okay, third, okay, entropy. Okay, and let me put another word here, space. Okay, these are three. Okay, and thermodynamics and economics. Believe me, how I set the paper for this. So that's why we have to have a separate one more revision. Thermodynamics and economics. Okay, thermodynamics and economics. So those are very important. Means thermodynamics for developments. Okay, economics and developments. Yes. So this is item 4. Okay, and of course technology. Technology. Okay, so these are 6 themes. So you have to get ready. Okay, this makes this very good. So this is what I'm planning. Environment. If our knowledge, if we don't see any connectivity with the environment, there is no value for our subject. If this has a connectivity with this, what's the use of this? This is the classic, the practical, usable, very important knowledge. If our knowledge has no place for this, there is no use. Also, we should recognize this. Okay, we should recognize this. And this subject is for you. Okay, this subject is for you. So I have to confirm this. So, but all connected with what we have learned. Okay, all connected with what we have learned, and questions will be well guided. Okay, questions will be well guided. So this is not applied thermodynamics, but still for mechatronics students, this is the formal learning of thermodynamics. So you have to think about them, because manufacturing we will be meeting again for applied thermodynamics. But for mechatronics, this is the last formal learning, first and the last, unfortunately. Yeah, you should have thermodynamics for applications. Mechatronics, actually, it is very good if you can have applied thermodynamics session. But you don't have, but semester 3, manufacturing students, they have applied thermodynamics. Anyway, so we will look into this themes. So when it comes to themes, so
yes, sir.
I will share with you the themes I have done for this time question papers. Yeah. Themes. This is very interesting. Yeah? So themes I have done for the question paper. I'm teaching a subject we call innovation management. Okay, I'm teaching this for management students. So let me.
Again, after
මොකද පුතා?
විභාගෙ තියෙනවා සර් කියන්නේ.
ඔව් විභාගෙ තියෙනවා. Management student.
කවුද සර් තියෙන්නේ?
මේ මාසේ තියන්න ඕනේ පුතා විභාගෙ. So this paper I said for a theme. It is okay to share with you, no issues. These are the themes. So one theme is, this is for your interest I'm sharing. One theme, you and your country and innovation. Quite interesting, eh? Another theme, this has only two themes, okay, part A and part B. Another theme is this. So this time I went on this too. Yes, that's right. So I'm very serious on somehow we have to derive a bottom line. So I'm okay for the sharing the themes. I have already shared the themes with the students also. So this one, so I put a weightage 70 marks for this. And the balance 30 is here. Here only 2 questions. That's right. I'm not troubling them, but I need to assess them. Here they have to answer 2 questions. Example, okay, example. So, because nowadays, not like last time, we should go for like this. So, another subject. I did for students, sustainable consumption and production. Semester 6. So, this one, even mechatronics students, I join in this. This one, the themes. I will share with you. Here is not the themes, but the concerns. Okay. See. This is one. Okay. So, another one. See, that's one. So at least we must have some meaningful, okay, questions, meaningful themes. Quite interesting. Okay. This is another one. Okay. One. This paper is already set. These are the themes, concerns. So all under this. These names are even in the papers. recipe. So nice. That's why we should have a purpose. When we teach, there should be a purpose. When we learn, there should be a purpose. When we evaluate, there should be a purpose. Otherwise, what for? Otherwise, what for? I will share with you one more. Yeah. Another subject. So I don't put the subject, but I will put the themes. Okay, I will put the themes. Subject is this. One of the themes. My enterprising integrity. Okay, so we are testing your knowledge on this. Yes. Okay. So this paper was moderated by a senior professor. Second one. My understanding on this. It's your understanding. Quite interesting. Okay. One more here. Summarized. All in one. One more thing. Okay. Groom yourself. Okay. Seeing the space, love the nature, genes, ancestors. Even I'm asking this. His Holiness the Dalai Lama, improving soft skills, understanding nature, becoming a leader. So, theme of another question. Okay, so valuable. That's why now you can understand that. Okay, it is very important. Okay, to go with the theme means we have a focus for the objectives. Objective focused. Another theme. Carbon emissions and global warming. Yes. Okay. And one more theme is there, so let me put it there as well. See, modern trends in environmental management solutions and approaches. themes. These are the themes. Okay. Some more here. The government's responsibility. As citizens, we should understand this. So one more theme is there, I'm not putting because that is enough. 7 here, 8 questions are there in the paper, so 7 questions is here. So one more theme is there for the 8 questions. So that's why here you can see 5 you are answering 4. See, untold knowledge. See, groom yourself. See how wonderful this are. So my understanding, okay, of what you can see government's role. My enterprising integrity. So this will be in the question banks, the past papers as for you. Summarize the knowledge all in one shot. So you can see that same way. Yeah. So here the challenge. Okay. So these are nice themes as well. So innovation management, 2 themes. You and your country. 17. Okay. So very nice questions. That's why. So in your case also there will be themes. So that's how we can make the subject meaningful. That's why we tried so hard to go beyond the words and equations and learn something. Okay. So there is a way of connecting to this. So then for the, of course, for you, this may be an advantage, but even for B1 students. So this should be good for them as well. Okay, this should be good for them as well. Even they also can score. So that's how this would be. So this, I will consider revision 3 as the final revision. Okay, revision 3 as the final revision. So go through this precious things. So as I mentioned to you, thermodynamics, Utala, there are no free marks. Okay, but I'm very reasonable. I'm very reasonable. So we are learning with the purpose. We share the knowledge with the purpose. And you have very good videos. Even I have shown you. Just got to only today I caught your notes. You have everything there. So no question out of the notes when it comes to calculations. Okay. The balance will be from our discussions. Okay. So it's a must to understand, and many of you, you can think and answer. Yes, you can think and answer because technology is, you have a huge ownership for the technology. Yes, some technology you can pick with no time. Okay, very fast. You can gain the knowledge and technology. Okay, that is very good. So that's all for today. So as a summary, where is the summary here? Yes, revision 3 and 4 today combined. So you may have around 2 to 3 questions for sure. Gas power cycles. I think I have done it and I have sent you the notes, and you can do it very well. So final revision, maybe we will do it before the exams. Okay, before the exams. Okay, Bhutala? Final revision we will do before exams. So that's all for today. Any questions? Okay, any questions? Ruben,
Oh, yes, sir.
you okay?
Okay, sir. Thank you, sir.
Yeah. So this is, I think this is complete. Speed is there, Hasita is there now? Yeah.
Sir, Pierre is suffering from fever, so
Okay. Okay, good. Anyway, you can ask any questions. No issues. We have plenty of time to do a revision. Even if you feel that some areas, interesting areas, should be included in the paper, just send it to me. Tunat arinyam. Okay, Bhutana. So if you feel that some areas should be included, now you have some idea how this is going. So even you can propose the areas. Yeah, I'm okay to accommodate this because your knowledge is my knowledge is your knowledge. Yeah. Okay, so that's why don't worry. So even I will try to put this, if possible, some of this into the question papers. But paper will be 7-8 pages easily because of the pictures and all. So quite different. Yeah. Okay, Bhutana. So wish you good luck, and any comments or anything before winding up today? So then let me conclude the class today, and next Saturday there may not be a class, but if you are requesting your design questions or some further continuations, anything, but I'm not putting those into the exams. So if you like to learn something, we can meet. Okay, that is based on your interest. Okay, that is based on your interest. If you have time and if you have to decide this to learn some more technologies, so whatever we can meet and discuss. And if possible, in the video uploads, there are innovation management videos done by me. So video quality may not be very good, but it's in like this. But even there are trainers I have done for some college lecturers, this Atmalana Mathur and all this. So they appreciated those, and those are in the uploads there. So you can freely go through if you are free enough and if you are willing. So those will help you really. Even nowadays, whatever ongoing this, this innovation management. So there are a lot of lessons there. So you can go through those. So this will help you for innovation parts if you are free now. So that's all, Bhutala. So,
sir, excuse me.
yeah, Bhuta, anything?
Kindly request, sir, could you please give model paper?
Bhuta?
Sir, could you please give model paper?
Yeah, that one for the model paper. So we will wait for a while, because
Okay.
exams are not around the corners. Yeah. So I'm yet to do the paper. So that's why I mentioned you that we will have a discussion before the exams as the final revision.
Okay, sir.
Okay, Buddha, that's why. So
Okay, thank
too
you.
early to set this, but please understand the subject. That is extremely important. That is extremely important. Please understand the subject. And the questions I post here, please do that. Those can be considered as model papers. Okay, so this is the guideline for even my setting of the question paper. So revision 1, revision 2 and revision 3, there are questions. Okay, please go through this, Putala. Okay, please go through this. Do this and send it to me. So if this solutions, if you can manage this, you can manage the questions in the exam, but paper is more than this, as I mentioned to you. Okay, so just solving, writing equation is not thermodynamics. So this may be part of that. Okay, this may be 30 to 40%. Okay, Bhutala, the balance, you have to receive the knowledge somehow. You go through the notes, go through the videos, read, go through the internet and all, learn about the entropy and all, have to have a very good knowledge. Okay, Bhuta? Good. So don't worry, we will look into the papers when we are ready for the exams. Okay. So that's all then. So take care all of you and good luck to all of you. If you have any problems, any questions, industrial issues and designs, we can discuss. Okay, we can discuss. Don't worry. So that's all then. So let me stop the class now. So I will email this. So let me email this now. So S2019 is 2B1 and B2, 6 March. 6 March, thermodynamics. Dynamics. March. Okay. Save this first. Save as PDF. So these are very precious notes. So even I didn't put my name or anything here. So no one knows the originality, but yeah, better to keep the notes with you. Okay. Yeah. So let me email this to you now. Dashed documents. Today 6 March. This is revision 3, revision 3. March. Revision 3. Okay. So your revision 3, thermodynamics notes. So notes attached. Okay, I just send it to you. So anyway, with the uploading of the video, I will resend it again because I have to send it to B1 as well. Okay, Bhutala, that's also. Wish you good luck and see you. Not next Saturday, maybe if you need, you can call for a lecture. If not, see you before exams. Okay, bye then. Bye.
Thank you, sir.
Thank you, sir.
Bye, Putala. Bye. Yeah.